Alright, let's look a little bit about similar triangles and some shortcuts just showing some similar triangles. So, remembering that if I want triangle ABC to be similar to, we're going to be using that symbol, and that means a couple things. First off, that means that angle A is equal to angle Y, angle B is then equal to angle X, and angle C is then equal to angle Z. It's no different from congruency, and it's the same with the angles. But now with the side lengths, we have to also remember that if I look at side AB, I'm not saying it's equal to YX anymore. I'm saying that YX, AB divided by YX is going to equal BC divided by XZ is going to equal AC divided by YZ. All the same triangles up top, all the same triangles below, and the ratio should equal something, and that should be some scale ratio that we look at. That's what we want to do. That's what we're using today. Much like congruency, there are 6 things we have to show. That's a lot. If we had normal class together, we'd go through and we'd create some of these similar triangles and we'd see what's there, but we don't. So I'm just going to be a spoiler and tell you that there are 3 shortcuts. The 3 shortcuts, very similar to what we had last time, pun intended. But there is angle, angle. We could say angle, 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 but if you have 2 angles, the third one's there. That's something that we've had before. So if we can show 2 angles are the same, they're going to be similar, no matter what. In a triangle, there is side, side, side similarity, but no longer is this all the sides are congruent. It's all 3 sides are proportionate to each other. And then we have side, angle, side similarity. And again, the angle is congruent, but the sides are proportionate, and the angle has to be between. So these are our 3. So let's look at these. So in today's homework, you guys are being asked to identify if they are similar. So you're going to look to see if one of these 3 things matches, and then you're going to write a similarity statement. So I'm going to do both those things for you today. So here is the very formalized angle-angle similarity theorem. So I have 2 angles that are congruent, and then I have my similarity statement. So here I have these 2 triangles, and I have 45 and 45. So I know n equals z. Awesome. And then I also have this angle here because of the vertical angle theorem. Don't forget about those. We'll look at another angle, nice angle theorem here for similarity that works out for us. So this does have angle, angle similarity. And I can say that I want to make sure that I mark them correctly. So I can say triangle NYM is similar to, and then what you guys will have to do in the homework is identify what these 3 letters are. So N goes with the Z, the Y goes with the Y, and then the X goes with the N. So there's my similarity statement, and those are similar. But let's look at this one down here. 35, 35, these 2 don't match, but we want to be careful because maybe 85 is this one. And so we can do a little bit of math, and we can come in here and say that I can come in here and look and do my 180 minus 35 minus 65, and it's 80. So this value right here is 80. So they're not similar. So we're going to say not similar. That's angle angle. We're just looking for that. Okay. So now let's look at the side lengths. So my next one is side, side, side. I want to show that all side lengths are similar. And so to do that, we want to make sure that we're looking at the entire side length. So make sure that if I want to show these 2 triangles are similar, I'm not looking at HG to GF. I'm looking at the entire side length. So maybe I might want to mark on here that I know that this length right here is 20. Maybe I want to make sure that I mark right here that I know that this length is 22. And and we can go from there. So let's check this. So if I want to make sure that I have all of them, I want to make sure that I set up each side length that's corresponding to the other one. And so we're going to kind of look through and see. I'm always going to compare certain side lengths to certain side lengths. That's how we know which side we're doing. And I'm always going to compare the smallest one to the smallest one. So if I look on here, the smallest one in my bit triangle up here is 15. So I'm going to write 15. And the smallest one of the larger triangle is 20. So 15 compares to 20. And I want that to equal. The medium one is 16.5. And I want that to be the same, or to be compared to the 22. I want that to be equal to the largest one of 18 over 24. So now let's just go through and let's look at each of those things. And so I can come over here and I can go to Desmos, and I'm going to compare each of those. So let's take 15 divided by 20, and we get 0.75. Let's take 16.5 divided by 22. 16.5, oh, 2070.75. So now, as long as 18 divided by 24 is 0.75, ding, 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 all of these are equal to 0.75. So it is similar by side similarity. I can write my triangle statement. Let's just go ahead and say triangle HGJ is similar to, again, this is what you guys will be doing. H. Well, I have HGJ, but then H is that same angle there, so I'm going to write H has to be compared to H, which is true. But then for G, I'm going down this line, so I'm going to compare that to F, and then the last one is K. So now, if I were to look at this one, I'm going to go, the smallest one on this side is 7, compared to the smallest one on this side is 6. The medium one on ABC is 8. The medium one on JKL is 7. And then the largest one over here is 12 compared to 11. Well, it looks, I mean, they're all 1 off. But let's go ahead and look at the ratio. So if I look at my ratio, I do 7 divided by 6 equals 1.16667. And then if I take 8 divided by 7, I get 1.14. They're not equal, so we're going to say not similar. So we're looking for that. And then we'll look at side angle side. So for both of these, we want to, it's kind of written out here. We're looking for 2 sides and the angle in between. So this one up here is a little bit tricky, and I can kind of look in for my 2 triangles here. I looks like there's a couple different triangles we can look at, really, and this is something we'll look at 9-4 here next week. But I'm just going to look at this triangle versus this triangle. I know that both those are right angles. So I'm going to go through and I'm going to see if I can show my 2 triangles congruent. So I already know I have a right angle. So I already know I have the angle checked. But now let's check the sides between those angles. So one thing I know is that the side opposite of this angle is 15. That's not the side I want. The side opposite is 20. That's not the side I want. I'm not worried about those. But let me compare this one. So I'm going to take, I'm going to look at this triangle first, my green triangle, let's say. The smallest side is 9. So then let's look at my blue triangle, let's say. The smallest side, that's right next to the right angle, is 12. And then I want that to be equal to, my next side is, on this side is that 12. And then I'm going to look at the next side being 16. And so those are the side lengths that are between this angle. So now when I go over to my Desmos, I do 9 divided by 12, 0.75, 12 divided by 16, 0.75. So these two equal 0.75. And because of the side angle side, I don't care about the third side as long as I have the angle between. So I can go ahead and say triangle WXZ is similar to triangle. This is what you'll be doing. W goes with X. Here in this case, X, WX. So I go from, that's a hypotenuse. And so I go W to X. I'm going to go from X to Y. And then I know Z on both of those is that right angle, so I'm going to say that's Z. But now let's look down here. So on both these triangles, so if I look at the green triangle versus the purple triangle, both of those have that angle K. So angle K is on both of those, and it's the same because it's reflexive. But now let's look at the side lengths here. So if I take my smaller side of the small triangle over the larger side of the large triangle, and then if I take my smaller side of the small triangle over the larger side, larger side of the large triangle, make sure we take the entire length here, I get 132. I have a ratio, but we have to go check it in Desmos. And so I come over here and I say, well, 16 divided by 88 is 181818. And then I have 25 divided by 132 is 189. So these are not equal, so they are not similar. And that is how we go through and look for similarity and make a similarity statement. There is one more thing that you guys will be doing, and that is using the idea of similarity to find the values of x. So let's see if we can set this up here. I know I have a couple different things on here that I can look at, but I know when I'm looking at them here, I have BE is congruent to, or sorry, is proportionate to XY. So I'm going to use that. I don't need to know what both ones for x is. We'll check with them just for kicks, but I can go ahead and say, okay, well, I know 5 to 10 is going to be equal to, well, this is EF. So that is 2x minus 1 over, notice how it's the entire thing, over EF, if I look up here, is the backside wall, which is 14. So now I can cross multiply. I think it might be easier to reduce first here. If I see this, that is really just 1/2, right? 2x minus 1 over 14. So I know that 14 equals, when I cross multiply over here, make sure I do the 4x minus the 2 as well. And then I add the 2 over, and I get 16 equals 4x, giving 4 the value of x. Now what happens if we did the other side? So I'll take that 5/10 as well. And let's go in and do 11 over 5x plus 2. And again, I'll reduce. 1 over 2 equals 11 over 5x plus 2. And then that gets me 5x plus 2 equal to 22. Subtract the 2. Get 5x equals 20. Give me x equals 4. So either way we do it, we get the same value. The problem is it only has one x, and so you don't have to worry about it. But yeah, that's what you guys are looking through. Watch the video more than once if you need to. Email me with questions, and I hope you guys are doing well. This assignment is the last one due on really Thursday. Anything is okay that you guys turn in. Please don't work on Friday. I'm not working on Friday, but I will be here all day tomorrow to take your questions on this assignment or anything else you have.